So welcome. So today I'm going to show you some new Cassandra 3 features for developers. So who is familiar with Cassandra here? Okay, some of you. Who is running Cassandra in production? Okay. And who is using Cassandra 3? Nobody? Fine. I hope that after this talk, you want to use Cassandra 3. So, my name is DuyHai DOAN. I'm working as the evangelist for Apache Cassandra. So I'm giving conferences and talks about Cassandra, and I'm working on the open source projects to support Cassandra. So Achilles, which is an object mapper, and I'm working on the connector between Cassandra and Apache Zeppelin, which is the notebook here. So if you have any technical questions about Cassandra, you can drop me an email or ping me on Twitter. I'm working for DataStax. So Apache Cassandra belongs to the Apache Foundation. DataStax, we are the biggest contributor to Apache Cassandra, the source code. And we have a product we call DataStax Enterprise, which is the open source version plus extra feature. So today I'm going to talk about Materialized View, the new user-defined function and aggregates introduced recently, the new JSON syntax, and the new full text search index. Materialized View. Until now, I used to tell people, please denormalize when you create your data model with Cassandra because we want performance, right? So denormalize means you need to duplicate your data. For example, here I have a user table. I can only access my user by ID. If I want to search my user by country, I need to create another table called user by country, and manually I need to handle the update. So every time I insert a new user, I need to insert a record into user by country. Every time I update a user country from the base table, I need also to update this table manually. And that's why we created Materialized View. So now with this syntax, you can create a view, okay? You can select which column you want to denormalize from the base table, and you define a new primary key. So basically, in the background, it will just create exactly this table for you. And what is interesting now is every time you update the base table user, Cassandra will update automatically the view for you. So insert, update, delete will be handled automatically for you. So let's see some demo. So here I have a table artist, okay? And I create a view, artist by country, so I can search artists by their country. So here is some example. So give me all artists in USA, in Poland, for example. Okay. This is all the artists in Poland in my data set, okay? So you have the artist name, the born date, the die date, the gender, and the musical style, okay? Now, let's say I want to insert into music, artist, ID, name, and country, of course. UID, name Alice, the country is Wonderland. Let's do that. Artist, wait. Oh, S. Artist. Here we are. Okay, and now let's query the data. So give me all the artists from Wonderland. You see, Alice. So it's updated in real time. I didn't change anything. I just create a new record into artist and my view is updated. Now let's say I update Alice country. Let's say that I move Alice from Wonderland to Zeppelin. To some other country. Okay. Update. Set country is, I don't know, Nightmare. Where ID is this one. Okay. So now if I'm looking for Wonderland, there is no result because I move Alice from Wonderland to Nightmare. And now here we are. Okay. So it works for insert, update, and of course, if I delete the user, Alice from the user, where I table. Now the view will no longer contain Nightmare. Okay. So you have insert, update, delete, automatically handled for you. The performance of Materialized View, of course, because we are denormalizing, we are duplicating data from the Cassandra side, it is a little bit slower than normal write. We have a local lock plus a read before write cost. But this cost is paid only once. So even if you have 1, 2, or 3 views, the cost is paid only once. Okay. And for each update in the base table, you have extra mutation. The number of extra mutation depends on the number of views. If I have 3 views, I will have 3 times 2 because I have a delete plus an insert. Okay. But if you compare the Materialized View performance to the case where you have to do manual denormalization, it will be better because you don't need to fetch any more the data from the cluster to the client side. Okay. And it makes your life easier as a developer because you don't have to handle all the updates anymore. The consistency level of the Materialized View is weaker because every time you update the base table, Cassandra will update all the view using consistency level 1 only. If you are using quorum in your update for the base table, the update of the view is always done with 1, consistency level 1. So you have weaker guarantees for consistency. Any question so far? Sorry? No. It is hard-coded to 1. The reason is that imagine that you update a base table at quorum, and you have 5 views. And if we update the 5 view at quorum, you imagine the contention. So it is very expensive. So that's why we choose the update is using consistency level 1, and we are doing an asynchronous update. So we don't lock, we don't wait for the answer of the update. We just push the update asynchronously. And hopefully we are using a batch lock. So if the update fails because of network connection or something like this, this will be retried by the batch log. Now, what we do is on the write pass, when you are writing to a base table, we look if this base table has any view. And if it has, we do a local read, and then we create the insert and the delete to the appropriate views. User-defined functions. So this is the syntax to create your own function in Cassandra 3. You have function name, create or replace function if not exists, function name. here you have to specify the parameters and the type. Okay, so the type is a Cassandra type, okay, not Java type. Call or null input means that your function will always be called, even if your parameters are null. We don't check for null. It means that in your source code, you have to check for null value. Otherwise, you will get null pointer exception on the server. Or if you want to be very conservative, you can choose return null or null input. In this case, every time there is a null value in your parameters, just one null value, Cassandra will skip the function execution. It will not execute the function and return null directly. Okay. In this case, we will not have null pointer exception, of course. You can choose the return type, so it will be a Cassandra type. It can be a primitive, a collection, list, set, or map, tuple, or user-defined type. You can choose the language. So out of the box, we support Java as language and JavaScript also. You can also run Scala or Groovy or JRuby, Jython, but you need to add extra jars on the server. Okay. Don't use Clojure because they have some issues. Okay. So some demo. I have some artists, okay? So let me show the artist. So the artists have a born date and a die date, okay? So my idea is how can I compute the age of each artist? So now I'm going to create a function compute age, okay? If the born date is null, well, I return null because if you don't have the born date, you cannot compute the age, okay? Otherwise, I need to extract the born year. So because the formatting is not the same for each artist, it can be years, month, day, or year, months, or just the year. So I am using some regular expression. If the die date is null, it means that the artist is still alive. So I just need to take the current year. And then I perform the subtraction, okay? Die year minus born year. So just create this function. Finish. Now let's use it. I have some test artists. So here you see John Lennon. He was born in 1940, died in 1980, so he had 40 years old. Mariah Carey, she was born in the 70s, but she's still alive. And we are 2016, shows she's 46 years old. Okay. And for Tokyo Electron, because the born date is null, well, I just return null because I'm not able to compute the age. Okay. So very simple. User Defined Aggregates. In fact, the function, user defined function, is here to be able to create aggregations. The idea is, if I want to compute aggregate on Cassandra, until now I need to fetch all the data from the server back to the client, and then perform aggregation. Now the idea is to push the aggregation directly onto the cluster. Okay. So here is the syntax. Create or replace aggregate, aggregate name. Here you only define the type. You don't need to define the parameter name. You need to define a state type and the initial value of the state, and also an accumulator function. So what does it mean? It means that aggregates in Cassandra works like a MapReduce. Okay? If you are familiar with Java 8 stream, it is working exactly like for left. Okay? You have the state, which is the accumulator, and then you apply the function to accumulate all the data into the state. So the signature of this accumulator function should be, the first parameter should be the state type, and the remaining parameters should have the same type as the aggregate types, okay? And the return type should be also the state type. Optionally, you can have also the final function to perform a final computation before returning the result. So let's see some demo. It will be clearer. So the idea is now I want to compute the style, musical style. So for each artist, I have a list of musical style, right? Rap, hip hop, blues, jazz, punk. And the idea is I want to know how many punk artists there are in a country, how many pop artists there are in a country, and so on. So for this, I first create an accumulator function, style count. Okay? The state is a map. The key of the map is the musical style. The value is the count. Okay? And as an input, I have a list of musical style for each artist. So if the state contains already the style, I just increment the value by 1. Otherwise, I initiate an entry with 1. Okay? And then I use this style count function for my aggregate. The initial condition for the state is an empty map. Okay? The bracket here is the literal syntax of Cassandra for map. So now, for example, give me all the musical style counting in Poland. So in Poland, for all Polish artists, I have punk, 10 punk artists, 100 unknown artists, 10 rock artists, and so on. If we choose USA, we have more artists. Okay. So there are lots more. They have a lot of rock artists, and so on. Okay. Be careful. Aggregates in Cassandra are not distributed. It means that the computation is not pushed onto each replica. It is done on the coordinator only. Okay? So do not use Cassandra aggregates on a large number of rows. For example, if you have a very, very fat partition, or if you want to full scan your table to aggregate, because it will be very expensive. So usually people, for analytics and for aggregation in Cassandra, they use Apache Spark. So people ask me, should I use Apache Spark to aggregate data, or should I use Cassandra aggregates? The answer is simple. If you are aggregating on a single partition, you can use Cassandra aggregates. Okay. But if you are aggregating on multiple partitions, it means full double scan. For analytics use case, Apache Spark is better, because the job is done locally by Spark. Okay. Any question? Yeah. Sorry? Yeah. So every time before applying the function, the coordinator needs to fetch all the data from the replica, well, based on the consistency level. If you ask quorum, it will take data from majority of replica and then compute the aggregation on the coordinator. So it will be expensive if you do a full table scan, because all the data will be fetched on a single node. Question here? Oh, no. Aggregation is done in real time. There is no pre-computation. We don't pre-compute. It's different than Materialized View. So when I execute my function here, select style distribution, it is recomputed on real time. So if you insert new data in the artist table or in the artist by country view, the result will be updated in real time. Yes. You can't. The reason is no. There is a very easy reason why we cannot execute the aggregates on different replicas. Because remember, in Cassandra, we need to reconcile last fragment. Imagine that on replica 1, you have different data than replica 2. So if we are executing the aggregates or the function on each replica, we may have wrong value, and we cannot reconcile. We cannot know which value is the correct one. That's why we need to fetch the data to the coordinator, resolve the value using the timestamp, and then apply the function. Other question? Yes. By paging. So the coordinator, no. The coordinator is using paging, server-side paging. So you will fetch like, okay, give me a page of 1,000 rows, and then it apply the function, and then the next 1,000 rows, and it will just update the state. Yeah. No more question? Yeah. So it means that your state will grow if you. Yeah. So that's why I said if you are doing a multiple partition, use Apache Spark. The aggregate of Cassandra is only performant when you are using on a single partition. Right? And consistency level 1 also. JSON syntax. Why JSON? Well, JSON is a good exchange format, okay, but it is a terrible schema. So terrible that some people are thinking about JSON schema project, right? Because there is no schema right now in JSON. So the idea here is you still use Cassandra schema, create table, but we convert the rows into JSON format for you. So you don't have to do the mapping. Some example. So here, let's create a table called JSON user. Okay. So in this table, I have the user ID, the name, the age, the country, the hobbies, which is a list of hobbies, and a list of addresses. Okay. Address is a user defined type. So here, I can use the new JSON syntax. So insert into JSON user, JSON, and now you need just to provide a big block of JSON, okay? And then Cassandra will just map the data from the JSON directly into the columns of the table. So ID, name, age, country, hobbies. This is the syntax for a list in JSON, okay? And now I'm doing a select JSON star. Also, instead of doing like select star, you can do select JSON star. Cassandra will return just a single column and format all the columns into one JSON text block. Okay. So with this, you can just take the result directly from Cassandra and push to your REST service. You don't need to convert anymore. We have also some update, some function. For example, for update, let's say that I will to change Helen Sue hobbies. So now she's like in cooking and politics. I will change it to cookings and movie. So I can use from JSON function to convert this string into a list in Cassandra. Okay. And the same for select. I can have the toJSON function to convert a list into a JSON string. Okay. So it's cool. We have JSON format. But what's about the schema? Imagine that if I do a mistake. For example, the hobbies, right? The hobbies should be a list. Imagine that I put a map instead of a list, key value. What happened? Error. Error decoding JSON value for hobby expected a list but got a linked hash map key value. Okay. So in fact, even if you are using the JSON syntax, we still have strong schema validation for you. Okay. Any question about JSON syntax? Yeah. The check, the validation is done server side. Yeah, I think we are using the library called JSON. It's not Jackson. It's JSON, some library like this on the server side. No more question? Clear? Yes, question in back. Oh, the micro? In the database, we convert the JSON back to the columnar format, okay, column ID, age, and then we store on this in a byte as a byte array. And in fact, all the type, when you see here the type of your column, so ID is an integer, name is a text, hobbies is a list of text. All those types are just metadata because the data which are stored on disk are just bytes, of course. And we are doing the decoding on the flight. Yeah, of course. Yeah, of course there is a small overhead if you are using the JSON syntax, because from the server side we need to convert it. Of course there is an overhead, but it depends on if you don't want to have to convert manually, you can use this feature. So it's up to you. There is no magic. Of course, if we are doing conversion, it will take some time, some CPU resources, of course. But it's very few, so it's okay. The last thing is the new full text search index. Okay. Why a new index? Because until now we have a secondary index interface in Cassandra that I recommend a lot of people not to use because it's so bad. The default secondary index in Cassandra. But now we have a new secondary index implementation. So until now, with the default secondary index for Cassandra, you have very limited search predicates, only equalities and inequalities, and also limited search scope, only on primary key columns, okay, of your index. Oh no, this is the default searching, and this is the default secondary index. It is using Cassandra as an index storage itself. So it stores the index data directly in Cassandra. So you have very limited search predicate. Now we have a new index structure. So we created a new index data structure from scratch based on suffix tree. So if you are interested, you can look on Wikipedia what is a suffix tree. Now we have extended predicate equality, inequalities, and like. We have this syntax now. So we can have full text search with tokenizer, stop word stemming. We have also a query planner. Okay, we are creating a tree of predicates, and we optimize all the predicates with push down. The index structure is following the life cycle of the base data. So if the base data is flushed on disk, Cassandra will flush also the index structure at the same time. Okay, and we don't use Apache Lucene for this. Who did this? Well, it is an open source contribution by an engineers team from a company I'm not allowed to say, but those information are public on GitHub, so I can just show them. Oh, those are public, okay. So some demo. Full text search. So I have a table called, let me create a new. Select star from music.albums. Limit 100. Okay. I have a table called albums. Okay. So I have artists, the country in which the album has been released, the year, and the title. So I have a lots of musics. I think I have like 112,000 albums. So don't do this in production, okay? Don't do count star because it will scan the whole cluster, okay? Don't do this in production. It's just for testing. And I want to be able to search my album. So I will create an index on the title, okay? Using a new index, SASI. Mod contains, it means that I will be able to search by substring. I will use standard analyzer with stemming, skip stop word, and normalize lowercase. I create also an index on the artist, mod contains, but this time I don't want to tokenize, okay, because I just want to be able to search by artist name. I don't want to split the artist name into different tokens. The same for the country. I want to be able to search on the country and on the year. So here we are. So let's see some albums from Poland which contain the word song. Okay, songs, okay. Now, let's say if we have some album which contains miłość. I think it is love, translation from English. Okay, there's some love in Poland. Is there any hate? I don't know. No hate? Marvelous country. Only love in this country. Really nice. Joy? Wow, yeah. Joy and love, okay. And I can also search so by artist. Like artist, so Maciej. I have been told that Maciej is very famous, right? Artist, so or Lady Punk. So let me show you the substring search. So like percentage, Punk percentage. It should return me Lady Punk. Yeah, Lady Punk. Okay. And now let's see some real full text search. So let me switch back to USA because I have some example. Dance. Okay. So give me all the songs which contains dance. So here you are, dance, dance, dance. Dances. Dances is also a good match because of the stemming, because it is the same word, okay? Dances or dance is the same word. Do I have some dancing? No. Oh, dancing. There is some. Where is it? No, because in this case, it will ask the index to give me all the title which contain the word dance or dancing, or it is full text. So if you don't put percentage, it is full text. If you put percentage, it is substring search. Okay. So I think there is some dancing, but I cannot find it. Dancing. Well, wait, it say 1 of 3. And for example, chair, if I put chair, it will give me also chairs, okay? Because it's the same word, chair and chairs, the plural. And now if I dance, chair, country USA, let's see. Okay, also here, the chairman dances. Chairman is the same word as chair, okay? And dances is the same word as dance. So in fact, in this case, it is working like an OR clause, where title contains dance or contains chair. Okay. So this is full text search here. It is already available from Cassandra 3.4, but because I have found some bugs, I recommend people to use Cassandra 3.5 or later. There will be improvement for this index in the future. So for example, we will be able to index on collection, so on list, set, and map. We will add an OR clause where blah, 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 or blah, blah, blah. Okay, so exactly what you have in SQL. And we will also support the different operator, not equal operator. So people ask me, how does it compare to a real search engine, like Elasticsearch or Solar or our data text enterprise search? Be careful, Cassandra is a database. It is not a search engine. So with this new index, we have search capabilities, but it will always be slower compared to a search engine, because every time you are doing search with Cassandra, you have 2 passes on disk. The first pass will read the index file, and then the second pass will read the original data from Cassandra. When you are using Elasticsearch or Solar, you are just reading the index, okay? There is no scoring, because we don't use Apache Lucene. There is no ordering, no grouping. So if you don't use all those advanced features like scoring, ordering, or grouping, it is fine for you. You can use this new index. If you need scoring, ordering, maybe a real search engine is a good solution. Okay. Question? Yes. Yes, there is, because every time you insert data, if you have indices on the table, it will also update the index in memory. And when the data are flushed on disk, Cassandra will also create at the same time the index files. And every time you have compaction, it means that the data files are merged together. The index files are also compacted. So you have an extra overhead on disk. Of course, there is no magic. Other question? Yeah. Sorry, this. Yes. Oh, the question is for the stemming and subword, is it configurable or only for English? It is configurable. Local, you set local here. So in my example, I set the local is English, but I can switch it to Poland PL. It will work. The problem in my data set is that with my album table, I have different languages. So it is not working very well because the stemmer is for English and I have Polish here, so yeah. But you can choose your language here. Other question? Yeah, at the index creation. Or if you do a mistake, you can drop the index and recreate it, so it will be recreated with the correct language. No more question? Oh, yes, here. Can you speak louder? Yeah. Zero? Because it is, if you don't use it, zero. It is opt-int. So yeah, if you don't use user-defined function, well, it will work like the old Cassandra. If you don't use the new index, it will work like the old Cassandra. So yeah. So you have the choice. Of course, if the more feature you add, and the more overhead you will have, there is no magic. But it's your choice to use those features or not. Sometimes people, they are complaining because they cannot have very simple search, multi-criteria search with Cassandra, and they need to install an additional cluster of Elasticsearch, and then they need to synchronize data between Elasticsearch and Cassandra. They need to manage an Elasticsearch cluster plus a Cassandra cluster in production. And this kind of index can be a good answer if they need very simple search, right? No more question? Okay, thank you.